بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه ومن والاه. Inshallah, we will continue with the proof for the select algorithm. Basically, this is where we stop. We stop at the recurrence Tn equal T, the floor of n over 5, plus T of 0.7n plus 1.2, plus T times n. And in order to solve the recurrence, we saw that in the book, in chapter 1, there is theorem 1.5, which gives actually similar recurrence, but with f of n equal f of the floor of C1n plus f of the floor of C2n plus Tn. So we would like to bring this recurrence to basically look like this. Not only that, but we want to make sure that C1 plus C2 to be strictly less than 1, so that we can use the theorem which says that f of n in that case is actually big theta of n. Is big theta of n. So let me try to connect from here, and I will share my screen. Okay. Very good. So let's come here. Okay. So now we know exactly what is the objective. So the objective is I want to replace this by using the floor function of some t multiplied by n. The problem here is the 1.2, right? The problem here is the 1.2. Okay. So now this is what I will do. Okay. Now let me ask you the following. If I say 0.7n plus 1.2 is less than or equal to 0.75n. Now, why did I choose 0.75n? Well, here, what do we have? We have the floor of n over 5, which is 0.2n, right? So this is 0.2, and this is 0.75. 0.2 plus 0.75 is 0.95, so we are less than 1. So we can use the theorem, right? Now, one thing that I would like to mention here is, for example, I cannot use 0.7n plus 1.2 less than or equal to 0.7n. Why? Because actually the left-hand side is actually greater than the right-hand side, because I have the plus 1.2, right? But now when I say 0.7n plus 1.2 is less than or equal to 0.75n, well, now I'm sure that, well, there is an n0 such that 0.7n plus 1.2 is less than 0.75n. But again, what I need is, I need this to be less than or equal to the floor of 0.75n. I need this to be less than or equal to the floor of 0.75n. Now, how can I ensure that? Okay. Now, look at this. So, do you agree that if 0.7n plus 1.2 is less than or equal to 0.75n minus 1, doesn't that imply that 0.7n plus 1.2 is less than or equal to the floor of 0.75n? Let's think about it a little bit. See, this is 0.75n, and I want 0.7n plus 1.2 to be less than or equal to 0.75n minus 1. So I subtracted 1. Now, the floor of 0.75n is at most you know, the 0.75 n minus 1. In fact, it will never reach 0.75 n minus 1. It will be 0.75 n minus some epsilon, which is less than 1, which is less than 1. So if I can ensure this, I know that 0.7 n plus 1.2 will definitely be less than or equal to the floor of 0.75, right? Okay, so let's see now, when is 0.7 n plus 1.2 less than or equal to 0.75 n minus 1? Because I want to get the n0. When is that true? Well, this is true if I bring the 0.7 n here and bring the minus 1 here. So it will become what? It will become 0.05 n greater than or equal to 2.2. 0.05 n is greater than or equal to 2.2, and therefore n is greater than or equal to, and guess what? Do it on the calculator. 2.2 divided by 0.05 is actually 44, which is the 44 that is in the algorithm, if p is less than 44. So that recurrence holds for p greater than or equal to 44. If p is less than 44, we can just sort and return AK. We can just sort and return AK. So therefore, for n greater than or equal to 44, so now I can write P of n to be equal to P of basically the floor of 0.2n, which is the same as n over 5, plus P of the floor of 0.75n plus some constant multiplied by n. And of course, the base case, this is equal to some other constant b, right? This is for n greater than or equal to 44, and this is for n less than 44. Now we can go back to our theorem, which basically actually the theorem was in the desktop. So now since 0.2n plus 1, there is no n. Since 0.2 plus 0.75 is equal to 0.95, which is 50 less than 1, by theorem, let me get that theorem number, by theorem 1.5, by theorem 1.5, P of n is in big theta of P of n is in big theta of n. So now we can write the recurrence relation for the selection algorithm as follows. P of n is the floor of 0.2n plus T of the floor of 0.2n plus T of the floor of 0.75n plus Tn for n greater than or equal to 44, and equal to some constant b for n is less than 44. What do we use to solve this recurrence? Basically, theorem 1.5 from 1.5 from textbook, and with this, we basically prove that the selection algorithm actually runs in big theta of n, and therefore P of n is in big theta of n, which is better than the solution where we sort and then return the smallest element. I think that's it. جزاكم الله خير for listening. السلام عليكم ورحمة الله وبركاته.